In this project, guided project, I will be making tic-tac-toe. This is a turn-based game with two players, so you'll have to keep track of who is the current player, X's or O's. It is played on a grid, a 3x3 9-cell grid, like shown. And you win by getting 3 of your own marks in a row, either column, row, or diagonal. So I think everybody's probably played this game. It's pretty simple. It's not that hard to make. A little bit of math involved, mostly having to deal with coordinates, trying to figure out which cell of the grid you're in with your mouse when you click, and then based on where you click, knowing where to put the mark on the drawing. So a little bit of math there, and I'll explain that as we go. Also a little bit of some new stuff with what we call Boolean values. So a Boolean is a variable like x. X in algebra could be 10 or -3. But when you have Boolean variables, those things have values which are not numbers, but they're either true or they're false. So it's usually conditions like x is even. X is even is called a conditional, and when you plug in a value for x, like 3, you get a predicate. Actually, I think I got that backwards. It's called a predicate, and then when you plug it in, you get a conditional. So x is even. If I set x to 3, then I get the statement 3 is even. That evaluates to false because 3 is not even. So if I put in a number like 4, though, 4 is even, and then it would be true. So if you have something like that, a conditional, that could either be true or false, and you store that in a variable, we call that a Boolean variable. That's from George Boole, a guy who did a lot of work on the math of this stuff. So Boolean is a Boolean. So that's something whose value is either true or false. And if you ever get into electronics, it's also used to represent high voltage or low voltage, or 1 versus 0. But in Boolean logic, it's the states are either true or false. So it's binary. It can only have one of two values. So we'll be using some of those in this project. So let's just start going over what we have to do. So it is a turn-based game, which means that it's not a real-time gameplay. It's turn-based. It's not a simulation. So the game just sits there doing nothing until you click, and then it runs an algorithm very quickly based on where you clicked. So it responds, and then it updates the game state, shows the changes, and then it just sits there doing nothing until you click it again. So this game is pretty static until you click, and then it only responds. But otherwise, all it does is it sits there. I guess I shouldn't say doing nothing. It just sits there listening for the click event. And then when you click, it responds. Other than that, it doesn't do much. So we're still a couple projects away from real-time games or simulations, but we're getting there. Okay, so here's a little bit of the math that we'll need. We're going to make, so the grid I'm going to draw is going to be a 300 pixel by 300 pixel box. So I know how to draw my lines. I want to go 100 pixels in for the first line, and then 200 pixels in from the left for the second line. Vertically, same thing, 100 pixels down, 200 pixels down. That'll help me draw my lines. Now, when we need to know where the center of the cell is, however, when we want to draw something. So now the mouse could be anywhere in the cell. So if I click here, I want to draw a circle at the center of the cell that my mouse is in. So my mouse could be all over the place, but so what I need to do is I need to take my mouse's coordinates, which could be pretty much anything, and I need to figure out which cell I'm in, and I'll know which cell based on this sort of a coordinate, an x and a y coordinate. So rows in computers you count from 0. So this is row 0, row 1, row 2, and then column 0, column 1, column 2. Now the marks are 1/3 of the width and 2/3 of the width. Also 1/3 of the height and 2/3 of the height. That's where I draw the grid lines. But the centers are 1/2 of a third. So I'm either going to be here I'll be so 1/2 of a third is a 1/6. So if I wanted to go into the center of a cell, I would go 1/6 to the right and 1/6 down of the width of the height. So for me that'd be 50 pixels. So 50 pixels right, 50 pixels down. That's the middle of my 100 by 100 cell. If I want to go to the second place, I would have to go 150. So I add 100. So it's 3/6 or 1/2. This is half width here. And it's still a 1/6 of the height down. So even though the marks are at 1/3 and 2/3, the centers of the cell are at 1/6, 3/6, and 5/6 spacings. So I have the little math formulas that I've worked out, how you get that. So let's say I want to go, I know what row I'm in, and I want to figure out where I want to draw my X or my O. This is the formula I'm going to use. So I'm going to take my row, and I'm going to double it. So let's say row 0. If I double the X number, or the row number, and add 1 to it, all I have to multiply is by a 1/6 of the width, which in my case is 50, for 50 pixels. So the first one is 1 times 50, so I'll be here. If I'm in row 2, I'm sorry, row is, I should be using this one here for row. Is that right? Yeah, I think I got row and column kind of switched here. But they're basically the same because the width and the height are the same. They're both 300 pixels for the whole thing. So I'll go, 1/6, or I'll go 3/6, or 5, using these formulas. Now, if I have a mouse click somewhere and I want to figure out which cell I'm in terms of these coordinates, what I can do, let's say I'm here. So let's say I'm at, let's say this is like 130 pixels to the right and 130 pixels. Well, we'll say here. So 130 pixels to the right and maybe, I don't know, 40 pixels down. So what I'm going to do, let's deal with the row that I'm in. And again, I think I've got row and column switched here. To figure out which row I'm in, that's vertical, so I should be doing that. I should have these switched. If I'm at 40 pixels, what I want to do is convert that into a 0, because I want to be in row 0. So either if I'm at 40 pixels, if I'm 90, 75, whatever, if I'm in here range-wise, I want to be in row 1, or in this, I should say row 0, the first row. So what I do is I just take that number, my mouse Y position, I divide it by by 1/3 of the height. My formula might be a little screwy here, actually. What I want to do is I need parentheses kind of around. This should be a times. Sorry, I made this kind of too quickly, I guess. I think right after the 3 should be a multiplication symbol. Same here. So I want to divide this by, no, it's the first slash, that should be a multiplication symbol. I want to divide this by a third of the height. So I should divide by h and multiply by 3 with my y position. So if I'm at 40, if I divide by 100, I'll be at 0.4, which is a third of my height. That's 100. So if I divide by 100, I'll be at 0.4. And the floor function says get rid of the decimal. So if I'm at 0.4 when I divide by 100, then when I say floor, it's going to go to 0. So that gives me row 0. If I'm at, let's say, 130 and I divide by 100, then I get 1.3. And then the floor function will strip the decimal off and it'll just give me 1. So if I click anywhere in here, I should get a coordinate of 1 for my row. So a couple mistakes here. I think my row and columns are, row should go with the vertical and column should go with the horizontal. I did that backwards. And this first slash should be a star. So let me see if I have that in my file. See if I can fix that real quick. So it usually goes row column this way, and then so this should be column. Oops. This should be row. Say column row. That should be star star. So I'll fix that. I did not get it. Oh. Delete the old one. Put that in here. So hopefully that's a better reference for you. Okay, so you can look at that when you want to make reference to this. So that's the math we're going to use. We're going to use these formulas. In my case, both height and width of the box is 300 pixels. So that's what H and W are. They're just 300. So this would be dividing by 100 and dividing by 100. That's the effect. The next bit, what happens when I click somewhere? What do we want to do? So if a player selects a cell, we're going to check to see did somebody already click in that cell. If they did, we don't accept the click. If they didn't, then we're going to let them make a mark. We're going to record the mark, display the mark, and then switch players. So we are going to need a way to indicate whose turn it is. So the first thing when you click a cell is it already marked? If it is, just do nothing. But if it's not marked, we're going to record that the player has made a mark. We're going to visually show the mark. And then we're going to do something where we check to see if the player has just won the game after that last mark. If yes, we need to indicate somehow that the player has won. And if not, we just switch player. And then that turn is over. Either way, that turn is over. Then, if the game's still going, the next player will have their turn, and then when they click, it does the exact same check. So that's pretty simple logic here. The difficult thing is checking to see if when you've won, and I guess representing the game in some way so that you record the marks that have been made, and you check to see if things have already been marked previously when you click it. So this will be, I guess, we'll start building this, I guess, and then to finish the game, we'll work on this later. So I've got a couple more slides to go over that go with checking to see if you've won. I'll do another logical requirements bit for these last slides once we get some of the project built. I guess this first part here, and then we'll move on to this. All right, I'll see you in the next video.